So now on to combustion. If you were to think about this without looking at reference and you ask yourself, okay, picture what happens in the real world. I think many of us would imagine a bomb, it's falling on the ground, and the area that that bomb occupies isn't very big in comparison to the explosion itself. I mean, if a bomb went off down here, that canister that holds all the fuel must be pretty small, like right about that size. But the shock wave itself would be, or I guess the visible explosion would be all the way out here, right? And so if we were trying to make this physically accurate, you would try to start with a small source like this, which then expands into a huge fireball. However, this is where we start running into some technical problems with the way in which simulations work in 3D. Because to get from a small canister to all the way out here is possible, but it requires a whole lot of sub-steps and a whole lot of thinking in between solves to actually go from, let's say, frame 1 to frame 2, where it's all the way out here. So because we have to think about all of that expansion in about one frame or so, it's really not the best way of doing it when simulating this with computers, because it has to think about all of these in-between spots to give you something that's sort of accurate to that. And we will talk about the CFL condition, and we will talk about how to add extra substeps adaptively to your simulation to get these extra things when you need it, to get the extra substeps when that's most needed. However, in this case, it's really not what you want to do for most situations. Instead, we're going to break off of what we think happens in the real world, and we're just going to try to copy reference frame by frame. So going through the reference now, if we play some of these hits, let's go frame by frame and look at the shape of this. So frame 1, pretty small. Frame 2, we have all of these bubbly shapes coming out. And what you'll find with most explosions is that we have this bubbly shape, and then we have spikes go through it afterwards like that. For the next bomb, over here, it's hard to tell what that is because it's covered by trees, but by this frame we can see that we have a spherical blob going on, and again, spikes come up, like that. In this bomb right here, we start off with this shape. So first frame, we have this. And so the idea is that as we take a look at reference and the specific explosion that you want to make, try to make this shape as closely as possible in SOPs. That's going to be our approach, because we don't want to think about the small canister going from, a very small area to this shape. Instead, we just want to kind of skip forward to when the explosion is at this shape. And then from there, we can let the solver do its thing. But I'd say for the first few frames, just copy what's happening here. So if we have a mesh that looks like that, and then it turns into that, and then it turns into maybe something right about here, we can have 3 meshes basically transform to those various shapes, and that will match what we see here in reference. It's probably the most accurate way of going about something that you see in reference. Something else that's kind of interesting is that reference will occasionally give you hints as to where the velocity is going. In this example, we start with this blobby shape. We can basically take a bunch of spheres, deform them, combine them all together until we have this. But notice what's happening right there. We do have a little bit of what seems to be thinner smoke, or that could be even refraction, who knows. But we can tell that the velocity is going in that direction. And so when sourcing for combustion, yes, we're trying to get the fireball and where that exists. But if we examine reference, sometimes we can tell where this is going based off of little clues like that. So in this case, I would also try to source velocity going in that direction, perhaps just for these 2 plumes. So even for your really spiky explosions, it only happens for a few frames. This is the first source. That would turn into this. So I'd go through, make all those blobs, and it would pretty much stay the same. So sometimes you need only 2 pieces of mesh to get what you need. Then the spikes come through and the debris, and that's what we have. We basically have a blob. A blob that is in the shape of the terrain for the most part. That then becomes the spikes. And something to think about here, which is interesting, is this. We have all this pressure happening, right? What's happening to the pressure when it goes towards the ground? And this might illustrate what's really happening here, okay? Because when we have pressure that's going down towards the ground right there, it's going to bounce off that ground and it's going to become the spikes, right? That's what we see right here when it becomes that. So if you're wondering where those spikes come from, it comes from the initial combustion. We're not going to actually rely on the combustion for the shape of those spikes, but that just goes to show what's happening in the real world right there, and how even having that collision mesh will make a big difference when it comes to the resulting velocity as it bounces off the ground. Let's take this guy now. As soon as we hit, we have fuzzy blob turning into another fuzzy blob. We have a bit of density laying on top though. And so what we can do to really add detail to this is we can have another source that is giving density, but it has a slightly different seed to the noise pattern that is being sourced. So when we source the combustion, we're trying to make it look as close as possible to what we see right here. That means we can have density with a slightly different noise than the combustion itself, and that will give us that layered looking effect. That then becomes this. So maybe we actually add a little bit of extra blobbiness to the base of that fireball, and then it evolves with the spikes. The fuel is ejected and it doesn't die off very quickly because this is a gasoline explosion, and that's what we have right here. And the whole explosion is very puffy because of that. This guy is interesting. So if you wanted to source the combustion for this, how would you do that? Well, we start with this blob coming out of the ground. But what happens there? We already have seen this before. We know it's going to go to the sides. So we wouldn't want to source a lot of temperature going up, right? Instead, we can also source velocity with this. And we can make custom velocity vectors in whatever direction we want. So in this case, if you made some going that direction away from the bunker and going the other direction, that could push the resulting smoke outwards like that. And that's how I would go about this particular combustion. But really, that whole source only lasts for about 3 frames and then it's gone. Taking some of these ideas further, how would you source this? We're going down. We have combustion. Maybe we start with these blobby shapes right here. Next frame, we have this. Now, if this was to just simulate normally, the smoke would go upwards, right? But again, if you define custom velocity vectors with that combustion source, guess what's going to happen? That fireball is going to go out that way. This guy's going to go that way. And even though in the real world, the shape of that is determined by the collision, it works better in Houdini to do this using a velocity source, because the collision is not going to naturally push these guys out the way that you want it to. You could do it with a little bit of pressure and have it kind of poof out, but it's better if you source it with the combustion itself. So some velocity vectors and defining perhaps these 3 shapes right here. That's what you would want to do to make this particular explosion. And then after that, the puffs go out. We have our spikes. There you go. And other things pretty much work the same way from here. The nice thing about this technique is that it can really accompany anything you see in reference. So the first piece of geometry that we try to make looks something like that. The next one would look like this. And again, we can kind of offset the density sourcing a little bit so that it lies on top. And then after that, the spikes come through and everything evolves like so. Although we mentioned that we want to follow this particular reference, I'm going to change this up all in the name of education. And I'm going to use a different one just to really show this method. So if we go to, I think it's about frame 55, yeah, or about 55 seconds in, we have this guy. Starts off as like a little source like that and goes all the way out to here. I want to show how we can take our source and do something similar to what happens right here. And one thing to keep in mind as well is that we're going to be taking the silhouette of these shapes and making geometry based on that. So with whatever reference you decide to pick, do try to keep the camera angle somewhat similar when you go to build this out so that the silhouette makes sense for the angle that you're looking at it from. In other words, if we took something over here where we have more of an aerial view looking down, the silhouette is going to look fairly different than what you might have down here at ground level. So just keep that in mind as you're going through reference picking this out. But we will take the silhouette of these shapes and in the next video turn that into geometry.